Hi students, today we'll be learning about ratios, proportions, and special right triangles. So what is a ratio? A ratio is a comparison between quantities of two things. For example, if there are three triangles and two squares, we can write the ratio as 3 colon 2, or we could say 3 to 2, or you could write as a fraction 3 over 2. So we're just comparing triangles to squares. So how many triangles to how many squares? Now, when two ratios are equal, they are called proportions. Oftentimes, proportions might have a variable in it, and in those cases, we will have to solve for that variable. In this problem, it says to solve for x in this proportion. So we have x over 4 equals 3 over 6. First step we do is cross multiply. Then we have 6x equals 3 times 4, which is 12. When we solve for x, we'll divide both sides by 6, and we will have x equals 2. All right, on to similar triangles. Let's learn about them now. Similar triangles have the same shape, but they do not need to be the same size. They could be larger or smaller. But all their angles have to be the same, and their corresponding sides have to be the same ratio. So for example, A to P, that ratio needs to be the same as B to Q and C to R. So when the angles are all the same and the corresponding sides have the same ratio, they are similar triangles. So let's take a look at these problems and see if they're similar triangles. So 8 and 12, 6 and 9, 10 and 15. Are their ratios the same? 8 divided by 12, 6 divided by 9, 10 divided by 15. 8 and 12 can both be divided by 4. 8 divided by 4 is 2. 12 divided by 4 is 3, so 2 over 3. 6 divided by 3 is 2. 9 divided by 3 is 3, also 2 over 3. 10 divided by 5 is 2. 15 divided by 5 is 3. Since all of these ratios are 2 over 3 and they're the same, that means PRQ and SUT are similar triangles. Also want to remind you that if triangles have all three of the same angles, they will be similar triangles as well. If you look at the first two on top, their angles are the same. If those two lines here, that where the x is and 32, if they are parallel, then the angles will be the same and it will be similar. However, if you look on the triangles on the bottom, put an X there because the last line there is not parallel. So because they're not parallel, the angles will not be the same and it will not be a similar triangle. And for this top triangle on the right here, those are vertical angles. Their angles are the same. And then here, if you draw the Z, it'll be the alternate interior angles. And if the alternate interior angles, they're also congruent. So since all the corresponding angles are the same, these two triangles are similar. All right, on to special right triangles. There's a lot of them, but here are the more common ones. Here's the 45, 45, 90 triangle and the 30, 60, 90 triangle. These are talking about the degrees in the triangle. The two sides are 45 and one side is 90. Because the two angles are 45 degrees, that means their sides, x and x, are also the same. And interestingly, the hypotenuse is the original leg, x, multiplied by square root of 2, and that will be the hypotenuse. It is a very special property of this triangle. For the 30, 60, 90 triangle, the angle with 30 corresponds with x, the angle with 90 corresponds with 2x, and the angle with 60 degrees corresponds with x root 3. A lot of times we call this the 1, 2, root 3 triangle. On the bottom here, the 3, 4, 5 and the 5, 12, 13 triangle are talking about the side lengths, and we will learn more about these later. These are called Pythagorean triples, and we'll see why they're special later. All right, so here's the 30, 60, 90 and the 45, 45, 90 triangle. This is like the basic one. So it's the 1, 2, root 3 or the 1, 1, root 2 triangles. Um, and once again, if you multiply it by anything, you can make it larger or smaller and it'll stay the same. All right, let's practice. So here is a 30, 60, 90 degree triangle and also a 45, 45, 90. So let's start with a 30, 60, 90 degree triangle because remember this is the 1, 2, root 3 triangle. Root 3 times what is 6 root 3? Multiply by 6. So what can you multiply by 1 to find t? Correct, you also multiply by 6. Let's just find the hypotenuse as well. What can we multiply by 2? We multiply by 6 because 6 is the ratio between that original 1, 2, root 3 triangle and this new triangle here. They are similar triangles. For the 45, 45, 90 degree triangle, we have to look at the two sides. 45, 45, that is the 1, 1, root 2 triangle. So that's the original triangle, and since this one is a similar triangle, let's take a look. So what can you multiply to root 2 to get 7 root 2? You multiply by 7. So what do you multiply by the 1 to get c? You also multiply by 7. So c is equal to 7. All right, to end us today is the Pythagorean triples. This is mainly using the Pythagorean theorem to find numbers that are whole numbers. So a, b, and c are whole numbers. So a squared plus b squared equals c squared. That work for these right triangles. A lot of times I don't memorize all of these. I just remember the 3, 4, 5, the 5, 12, 13, and the 8, 15, 17, and that usually is very helpful for me. For example, you could use the 3, 4, 5 to get the 6, 8, 10, because 3 times 2 is 6. 4 times 2 is 8, and 5 times 2 is 10. So remember, because these are similar triangles, you can multiply or divide them, and the ratios will still be the same. So those are also Pythagorean triples. So here is the 6, 8, and c triangle. It is very similar to the 3, 4, 5 triangle, and I can check that because 3 times 2 is 6, 4 times 2 is 8. So it is a similar triangle to the 3, 4, 5 triangle, except it's dilated by 2, or it has to be multiplied by 2. So all I have to do is multiply the 5 by 2, and that will get me c, and 5 times 2 is 10, so c is equal to 10. If I look at the next triangle, the 5, 12, and c, if I remember from the last page, there's a 5, 12, 13 triangle, so without having to do any calculations, I can know that c is 13. Looking at the last triangle, the 8, 15, c. What is c? If I memorize it from the last page, I would know it's 8, 15, 17. So I don't have to do anything. Once again, I will be able to find c. c is 17 because of the 8, 15, 17 right triangle. Those are the Pythagorean triples. If you memorize it, it can make your life much easier.